For as long as humans have existed, we have looked upward and wondered. Before we built cities, before we wrote languages, before we understood fire, medicine, or the shape of our own planet, we stared into the night sky. Ancient humans saw patterns in the stars and called them gods. Early astronomers charted the motion of planets and called it destiny. Modern scientists now map galaxies billions of light years away and still ask the same question. What is space? Is it just emptiness? Is it a physical thing? Does it stretch forever? Or does it have an edge? Did it begin? And if so, what came before it? Space is not just out there. Space is the stage on which all reality exists. Every atom, every star, every planet, every thought you've ever had happens inside space. And yet, the deeper we look, the stranger it becomes. We've discovered galaxies so far away their light started traveling toward Earth before a planet even formed. We've found planets orbiting other stars, worlds with oceans of lava, storms of glass, and skies glowing red. We've detected invisible matter holding galaxies together and a mysterious force pushing the universe apart. The more we learn, the more unsettling the truth becomes. Space is not what we thought it was. And by the end of this journey, neither will you. Before we begin, if you love deep space mysteries, cosmic discoveries, and the true scale of reality, subscribe to the channel and turn on notifications. This documentary isn't just about facts. It's about perspective. It's about understanding your place in a universe that is far bigger, older, and stranger than anything ever imagined. Now, let's begin. Long before telescopes, long before science, humans tried to explain the sky. In ancient Mesopotamia around 3000 BCE, early astronomers tracked the motion of planets and stars. In ancient Greece, philosophers like Aristotle believed space was a perfect, unchanging realm beyond Earth. In the 3rd century BCE, Aristarchus of Samos proposed something revolutionary. That Earth was not the center of everything. He suggested the sun was at the center, a heliocentric model. But the idea was dismissed. It wasn't until 1543 that Nicholas Copernicus revived this idea in his book De Revolutionibus Orbium Coelestium. And even then, most people refused to accept it. In 1609, Galileo Galilei pointed a telescope at the sky and changed everything. He discovered mountains on the moon, moons orbiting Jupiter, phases of Venus, proof that not everything revolved around Earth. Space was no longer a perfect, divine realm. It was a physical place filled with objects. Then in 1687, Isaac Newton published Principia, introducing gravity as a force that governed both Earth and the heavens. For the first time, space followed laws. But even Newton believed space was a fixed, unmoving stage. That idea would later collapse. So, where does space actually start? There's no physical wall or border separating Earth from space. The atmosphere just gets thinner and thinner. But in 1961, scientists defined an official boundary called the Kármán line at 100 kilometers, 62 miles above sea level. Above this altitude, air becomes too thin for aircraft. Orbital flight becomes possible. Earth's atmosphere fades into space. Yet even here, space isn't empty. Earth's atmosphere actually stretches thousands of kilometers into space as a faint exosphere, and particles from the sun constantly interact with it, creating auroras. Beyond that lies the vacuum of space, a region with incredibly low density. But not zero. In interstellar space, there is roughly 1 atom per cubic centimeter. On Earth, there are about 10 superscript 1 atoms per cubic centimeter. So space is not nothing. It's just almost nothing. And that almost changes everything. For centuries, scientists believed space was truly empty. But in the 20th century, physics shattered that illusion. In quantum mechanics, even a perfect vacuum isn't empty. It's filled with virtual particles popping in and out of existence, fluctuating energy fields, quantum foam at unimaginably small scales. This idea comes from quantum field theory, developed in the 1920s and 1930s by physicists like Paul Dirac, Werner Heisenberg, and Erwin Schrödinger. They discovered that nothing is unstable. Space itself seethes with energy. In fact, the energy of empty space is believed to be connected to dark energy, the mysterious force accelerating the expansion of the universe. So when we say space is empty, we're lying. Space is alive with invisible activity. Space itself had a beginning. In 1927, Belgian physicist Georges Lemaitre proposed that the universe was expanding. In 1929, American astronomer Edwin Hubble confirmed it. He discovered that distant galaxies are moving away from us, and the farther they are, the faster they move. This led to the idea of the Big Bang, a moment 13.8 billion years ago when space and time themselves began. In the early 20th century, scientists believed the universe was eternal and unchanging. Then everything collapsed. In 1915, Albert Einstein published his theory of general relativity, describing gravity not as a force, but as the bending of space and time itself. His equations predicted something radical. The universe should not be static. It should either be expanding or contracting. Einstein didn't like this, so he added a mathematical fix called the cosmological constant to hold the universe still. But nature didn't cooperate. In 1927, Belgian physicist Georges Lemaitre proposed that the universe began from a single, extremely dense point, which he called the primeval atom. 2 years later, in 1929, American astronomer Edwin Hubble confirmed it observationally. Using the Hooker telescope in California, Hubble measured the redshift of distant galaxies and discovered something shocking. Every galaxy was moving away from us, and the farther it was, the faster it was receding. This became known as Hubble's law. The universe wasn't static. It was expanding, which meant, in the past, everything must have been closer together. This led to the Big Bang theory, the idea that space and time themselves began 13.8 billion years ago. Not an explosion in space, but an expansion of space. At the very beginning, the entire observable universe was smaller than a proton. Then, in a fraction of a second, it expanded violently in a phase called cosmic inflation, proposed in 1980 by physicist Alan Guth. During inflation, space expanded faster than the speed of light. Not matter, not energy, space itself. This explains why the universe looks so smooth and uniform in every direction. And we have direct evidence. In 1965, Arno Penzias and Robert Wilson accidentally discovered faint microwave radiation coming from every direction in the sky. This radiation, called the cosmic microwave background, CMB, is the leftover heat from the Big Bang. It is the oldest light in the universe, emitted just 380,000 years after the beginning of time. The universe isn't just expanding, it's accelerating. In 1998, 2 independent research teams studying distant supernovae, the Supernova Cosmology Project and the Heisey Supernova Search Team, made a shocking discovery. Galaxies weren't slowing down. They were speeding up. Something invisible was pushing space apart. This mysterious force was named dark energy. It makes up about 68% of the entire universe. Ordinary matter, stars, planets, people, makes up only 5%. The rest is dark matter, which we'll come to soon. The observable universe today is about 93 billion light-years in diameter. That means the farthest objects we can see are 46.5 billion light-years away, even though the universe is only 13.8 billion years old. How is that possible? Because space itself has been expanding while the light traveled, and it's still expanding at an accelerating rate. When you look into the night sky, it feels empty. It's not. Space is filled with gas clouds, dust, radiation, magnetic fields, cosmic rays, invisible matter, quantum energy. Between stars inside our galaxy, there are about 1,000 atoms per cubic centimeter. Between galaxies, there's roughly 1 atom per cubic meter. And yet, these tiny amounts shape the entire cosmos. Stars form inside massive clouds of gas and dust called nebulae. One of the most famous is the Orion Nebula, about 1,344 light-years from Earth. It's a stellar nursery where thousands of stars are being born right now. Everything you see in space, planets, moons, asteroids, even your own body, is made from elements forged inside stars. Carbon, oxygen, iron, gold, all created by nuclear fusion and supernova explosions. You are literally made of star stuff. In 1933, Swiss astronomer Fritz Zwicky noticed something strange. He observed galaxies in the Coma cluster moving too fast. According to gravity, they should have flown apart, but they didn't. He concluded that something invisible must be holding them together. He called it dark matter. Decades later, in the 1970s, American astronomer Vera Rubin confirmed this mystery. She measured how stars orbit inside galaxies and found they were moving too fast at the edges. There wasn't enough visible mass to explain it. Dark matter makes up about 27% of the universe. It doesn't emit light. It doesn't absorb light. It doesn't interact with normal matter, except through gravity. Without dark matter, galaxies wouldn't exist. Then there's dark energy, discovered in 1998. It makes up 68% of the universe. It's driving the accelerated expansion of space. Together, dark matter and dark energy make up 95% of everything, which means we barely understand 5% of reality. On the largest scales, space isn't random. It has structure. Galaxies aren't scattered evenly. They form filaments, walls, and clusters. Between them lie vast, empty regions called voids, some stretching hundreds of millions of light-years across. This structure is called the cosmic web. It's shaped primarily by dark matter. Computer simulations in the 1990s predicted this web-like pattern, and modern galaxy surveys, like the Sloan Digital Sky Survey, confirmed it. Our galaxy, the Milky Way, sits inside a filament within a cluster called the local group, which itself is part of the Laniakea supercluster, spanning over 520 million light-years. Space has architecture, invisible scaffolding. Stars are not eternal. They are nuclear furnaces. In 1920, British astrophysicist Arthur Eddington proposed that stars shine because of nuclear fusion. In the 1930s, physicist Hans Bethe explained exactly how hydrogen fuses into helium, releasing enormous energy. Our sun converts about 4 million tons of mass into energy every second. That energy takes about 100,000 years to travel from the sun's core to its surface, then just 8 minutes to reach Earth. There are an estimated 200 to 400 billion stars in the Milky Way, and around 2 trillion galaxies in the observable universe. That means there may be hundreds of sextillions of stars, each one a sun, each one a potential home for planets. In 1916, Karl Schwarzschild found a solution to Einstein's equations that described a region where gravity becomes infinite. A black hole. For decades, they were theoretical. Then, in 1971, astronomers discovered the first real black hole candidate, Cygnus X1. In 2015, scientists detected gravitational waves for the first time using LIGO, ripples in spacetime from merging black holes. In 2019, humanity captured the first image of a black hole, the supermassive black hole at the center of galaxy M87, 55 million light-years away. At the center of our own galaxy lies Sagittarius A*, a black hole 4.3 million times the mass of the Sun, located 26,000 light-years from Earth. Black holes warp space and time. Time slows near them. Space curves into them. They're the most extreme objects in the universe. Galaxies come in many shapes: spiral, elliptical, irregular. The Milky Way is a spiral galaxy about 100,000 light-years wide. It contains around 200 to 400 billion stars. Our nearest large neighbor, Andromeda, is 2.5 million light-years away, and it's moving toward us. In about 4.5 billion years, the Milky Way and Andromeda will collide and merge into a new galaxy. Galaxies evolve. They collide. They cannibalize each other. Space is dynamic, not static. The nearest star beyond the Sun is Proxima Centauri. Distance, 4.24 light-years. That's about 40 trillion kilometers. With current spacecraft, it would take over 70,000 years to get there. The Milky Way is 100,000 light-years wide. The observable universe is 93 billion light-years wide. There are galaxies so far away their light began traveling toward Earth before our planet existed. Space is so vast that even the fastest objects humans have ever built barely scratch the cosmic map. There's a limit to what we can see, not because the universe ends, but because light has a speed limit. The observable universe is bounded by a horizon 46.5 billion light-years away. Beyond that, light hasn't had time to reach us since the Big Bang. There may be more galaxies beyond that, maybe infinitely more, but we can never see them. We don't know. Measurements suggest space is either infinite or so vast that it appears infinite. The geometry of space, measured using the cosmic microwave background, suggests the universe is flat, which allows for infinite size. But we don't yet have proof. The question remains open. Some theories suggest our universe is just one bubble in a vast multiverse. This is the deepest mystery of all. Space is not empty. It is everything. It is the stage of reality. It is the story of existence. And it is still unfolding. If this journey changed how you see the universe, like the video, subscribe to the channel, and share this documentary with someone who loves space. Because the greatest story ever told is still being written. This is the deepest mystery of all. Space is not empty. It is everything. It is the stage of reality. It is the story of existence. And it is still unfolding. If this journey changed how you see the universe, like the video, subscribe to the channel, and share this documentary with someone who loves space. Because the greatest story ever told is still being written.